When Pat invited me to speak, she told me she wanted me to talk about my personal story, and I said I'd really rather talk about our company, Alpha Space, and our place in the commercial space universe. So we compromised, and I'm going to talk a little bit about my 34-year quest to create something that still doesn't exist, commercial EVA services, and how our company, Alpha Space, there it is, and our orbiting commercial external testing facility, MISSE, is helping to move that forward a little step at a time by enabling a stronger supply chain. So my commercial space journey started in 1984, the year Ronald Reagan announced the space station program. After college, I enrolled in a trade school for commercial divers, and in 1984, I was living in Louisiana, and working in the Gulf of Mexico as a hard hat construction diver. And I distinctly remember one day right around that time standing on that very dock talking with a friend of mine, another diver, about the space station. And we were saying, and we convinced ourselves, that what NASA really needed to construct and maintain that space station was guys like us, commercial divers. We said, and this is a true story, NASA needed space divers. So that's me right around that time. And the other guy on the dock that day was Mike Gernhardt. And about 4 years later, Mike founded Oceaneering Space Systems, and he hired me with the idea that we were going to create a commercial EVA services business. Now, many of you probably recognize that name. Mike was selected a few years later to be an astronaut, and he's done some great things at NASA, including 4 EVAs. And I've been in the space business most of the time since, trying to move commercial space forward while also making sure to stay in business. So we did pretty well as an oilfield services company in the space industry. And we continued to look for and push commercial space opportunities, including with a lot of companies that you would recognize who have come and gone. And in 1997, I was promoted to division vice president. That was a couple years after I had co-authored a study for NASA to try to answer the question, could NASA enable a commercial EVA services industry analogous to commercial diving? And our answer was, well, yes, if they wanted to. All it takes is the right policy plus time and money. And we've seen exactly that with COTS, the right policy plus time and money. And now we have commercial cargo, and we will soon have commercial crew. However, in my opinion, even with the cost of launches coming down the way they have, I still believe that if we are ever going to see real unsubsidized commerce with human beings in Earth orbit, we still need two things. We need a killer app, and we need the cost of hardware to come down a lot. Even after all this time, I still don't know the killer app, but I've built a lot of flight hardware and a lot of complex subsea hardware too, and I have some pretty strongly held opinions on how to bring those costs down. So let me back up for a second. In 2010, I quit the space business and went back into the oil field, and for several years I ran a very large worldwide engineering and manufacturing business that designed and built subsea control systems for oil and gas drilling and production. It was this kind of stuff. And I saw firsthand what a robust, competitive, and innovative supply chain can do to improve safety, reliability, cost, and performance, even in a dangerous, expensive, and high-risk industry, which that certainly is. And that's what our industry needs too. I believe that our industry needs a healthy and competitive supply chain that is constantly innovating, constantly bringing new and improved products and services to market, and continuously either reducing prices or providing the same products for lower prices. And we need NASA and the companies at the top of the food chain to buy and use those products. And that's something that we can start doing right now. We can start building a competitive, innovative supply chain, an industrial ecosystem, by reducing the barriers to entry for new products and suppliers. So I'm going to talk now about the supply chain and about the companies that make the materials and coatings and components and parts and products that go into all that great stuff that we've been talking about all day and that usually get all the press. And that's where our company, Alpha Space, and our commercial testing facility on the ISS, MISSE, can play an important role. Because we reduce the barriers to entry for new and improved products by providing commercial turnkey testing services in the external LEO environment. So if you have something you want to test in space for an extended period of time, 6 months, 12 months, and get it back at the end and get data all along the way, whether it's a new material or coating, a new sensor, electronics, even something that moves, talk to me later, because we could have you on orbit by spring and we could have you spaceflight proven by summer. And given that you're all industry experienced in this industry, I think you'll be pleasantly surprised by our quote. So here's how it works. You deliver your thing to us. We integrate it in our carriers, and those carriers open as they're shown here. They're about 30 inches long, about 9 inches wide, and a little over 3 inches deep. We integrate, we do it in our facilities in Houston, where we've got a clean room, a thermal vac chamber. We package it up as pressurized cargo, and we deliver those carriers to be taken to the space station. When they get there, they're loaded onto what we call the MISSE transfer tray. It exits the GEM airlock. It's picked up by the Space Station Robotics System, installed on our fixed facility, our MISSE facility, where they pick up power and data. We take data at 1 hertz continuously, and we have exposure on RAM, wake, zenith, and nadir. We have 12 spots, so quite a bit of capacity, 12 slots for carriers. We control it all from our Payload Operations Control Center in Houston. And best of all, for many of our customers, you do get it back at the end. The carriers return, we swap them out every 6 or 12 months, deintegrate, and return your samples, your experiment, your product to you for further evaluation. So let me show you what it looks like in real life. There's our MISSE facility in the background, and in the foreground, you can see the SPDM moving into the MISSE transfer tray, about to remove one of those carriers using the microconical system, pulling it out. So closed like that, it's the size of a very large shoebox, swinging around to get lined up, and then coming in for installation. And you can see that this is a RAM carrier, so once that's open, everything in it will be exposed to the atomic oxygen environment, as well as, thermal and vacuum and all that kind of stuff. And just as a fun aside, that tool the robot's using was one of my early flight hardware projects. That's been on station operating for sure 20 years, maybe 25. So there it's being installed, and when the structural connection is made, the power and data connections are made at the same time, and we're in business. So now you'll see we're commanding it from the ground now, from our POC. I'll show you the carrier's opening. First, the one on the left. There it goes. There are 5 on orbit right now. We're going to ship 7 more in November. There's the next one. You can see some of the material samples in that as it was opening up, and then one more on the lower right. And then the last thing this video will show you is the camera trolley. Once a month, we take high-resolution photography. We do it at night so we get consistent lighting. And that 10-second trip that you just saw is actually a 30-minute trip. So, to try to tie it all together, how does this help make commercial EVA closer to reality? How does it help tip the scales? I think we've never been closer, and other people have said that today. I do believe that if enough entrepreneurs and enough product developers and enough manufacturers start bringing new products to market and they spend less to do it, everything gets better, one little step at a time. Competition goes up, costs come down, specs improve, and the industry grows. And one day, maybe, it might make commercial sense for someone to go to Louisiana and recruit some commercial divers to be space divers. Launch them on a private rocket to a private space station to construct or maintain that space station. Maybe not. Until then, though, I am declaring at least a partial victory. I may never do a commercial EVA, though I would volunteer, but someone will soon. And in the meantime, we do have MISSE to help move things along. It's commercial, it's outside, and our services are fixed price and turnkey. And I would say most importantly, we are lowering the barriers to entry for new products and new suppliers to come to market and create that vibrant supply chain and industrial ecosystem that I believe we so desperately need. Thank you.